Good day everyone, welcome back to my YouTube channel. Now I want to discuss to you about conic hyperbola. Concept of a hyperbola. So, a hyperbola looks short of like two mirrored parabolas with two halves being called branches. Like an ellipse, a hyperbola has two foci and two vertices. Then for any points P that is on the hyperbola, d2 minus d1 is always the same. Therefore, A greater than C for hyperbolas, the value of A and C will vary from one hyperbola to another, but they will be fixed values for any given hyperbola. Parts of a hyperbola, center of the hyperbola, then branch, vertex, then the foci of the hyperbola are inside each branch. The line going from one vertex through the center and enter at the line, this one, other vertex is called the transverse axis. Then A plus C minus say A equals to A. This fixed difference property can use for determining location. So C squared equals E squared plus B squared. This is the formula, where C is the distance from the center to a focus point. Then the fundamental box, this one, the value of B gives the height of the fundamental box for the hyperbola. The asymptotes pass through the corners of a rectangle of dimension 2a by 2b with its center at B and K. Then, equation when the transverse axis is horizontal, x minus h squared, then x minus k squared, divide e to e squared, then b squared equals 1. The a squared goes with the x part of the hyperbola's equation and the y part is subtracted. The center of hyperbola is at the point h and k in either form. Then equation with the transverse axis vertical, the a squared goes with the y part of the hyperbola's equation and the x part is subtracted. Then if you zoom out from the graphs, it will look very much like an X with maybe a little curvedness near the middle. These nearly straight parts get very close to what are called the asymptotes of the hyperbola. So, y plus minus b, a x minus h plus k. Then, if a squared is the denominator for the x part of the hyperbola's equation, then a is still in the line denominator in the slope of the asymptotes equation. If a squared goes with the y part of the hyperbola's equation, then a goes in the numerator of the slope in the asymptotes equation. Then graphing a hyperbola, so we need to graph x squared divide x squared minus y squared then b squared equals a. So the center is 0, 0. Then graph x squared minus 4 minus y squared divide 9 equals 1. So vertex is 2 and 0 and negative 2 and 0. So this is the graph. Then c squared equals 9 plus 4 minus equals 13 rather. Then c equals square root of 13, then equals 3.16. So the FASI is 3.61, then 0, and negative 3.61 and 0. Then finding an equation, find the standard form of the equation of hyperbola given FASI negative 7 and 0 and 7 and 0. Vertex negative 5. So when we need to graph, this is the graph. You can see that. So a squared equals 25 and c squared equals 49. So the given is c squared equals a squared plus b squared equals 49 equals 25 plus b squared equals 24, x squared divide 25 minus e squared divide 24 equals 1. Then, sketching a hyperbola, sketch the hyperbola whose equation is. So, when we need to sketch 4x squared minus y squared equals 16, then the solution is 4x squared minus y squared equals 16. So, 4x squared divided 16 minus y squared equals 6, divide 16 rather, equals 16 divide 16. Then x squared divide 2 squared minus y squared divide 4 squared equals 1. So this is the answer. Then other information, hyperbola can be fairly straight or else pretty bendy. So this is the graph. The measure of the amount of curvature is the eccentricity, where E equals C/A. Bigger values of A corresponded to the straighter types of hyperbolas, while values closer to 1 correspond to hyperbolas, whose graph curved quickly away from their center. Then hyperbola was given its present name by Apollonius, who was the first to study the two branches of the hyperbola. Euclid and Aristeas wrote about the general hyperbola but only studied one branch of it. That's all for today, and thank you.